Hi guys. Alright, in 8.2 we were looking at whether the mean or the median was the best representation of the data, or the best predictor of a data. Now we're going to take it a step further. Okay, so we found the median, but if we look at the data and the median, or the data is really spread out, then the median may not, it's better than the mean, but we may find that the median is not as, if the data is spread out, we don't know how good the median is going to help us, how much the median is going to help us, okay? So let's look at the data in these two tables. So we've got a football team, and they're having a tough season, so they're struggling to win games. So it's talking about this year versus last year, but I mean, these textbooks were written a while ago. So I'm going to take 2012 to mean this year and 2011 to mean last year. Okay, analyze the data in this sets a table. In which year do you think the football team performed better? Well, let's see. 2012, 0, 7, those are some pretty low numbers, but hey, up on this end, we got some pretty good numbers up here, including a 45. So he's saying they're not doing as well this year, but look at that 45. That's higher than any other value from last year. On the other hand, last year, the lowest number is 10, and we seem to be a little more toward the middle. So the points are spread out more in the second year, and they're a little closer together in 2011. Okay, so right now we're just kind of eyeballing data, and we don't have any numbers to back up what we're saying. So that's what we're going for today is, we're trying to determine which year the scores are more reliable, and we're going to do that based on something that I'm going to teach you today to calculate called the IQR, the interquartile range. Okay, so important vocabulary word here, calculate the 5-number summary. All right, for each year. 5-number summary means your minimum number, your Q1, your median, your Q3, and your max. And you're going to do that, should have left myself a little more room to make this here, for 2011 and 2012. Okay, so you would go into your calculator and stat, edit, and start entering that data. Okay, you probably don't need to watch me do that, so I'm going to pause for a second. So I got your data in L1, check it, make sure you don't have any typos. Stat, calc, 1 variable stats. Okay, and the 5-number summary, again, that's all the way at the bottom here. I'm going to pull that one out. Then we're going to do the same thing for the second set of data. By the way, somebody showed me a cool thing. If you hit stat and hit number 4 for clear the list, and then you have to tell it which list you want it to clear. So second one is L1, and you hit enter. It'll clear out L1 for you without resetting the memory. Okay, somebody showed me how to do that. Stat, edit. Again, I'm going to pause here because I don't think you need to watch me enter data. Okay, so these are the 5-number summaries for the 2 sets of data. This is the 2011. This is the 2012. Okay, then it says construct box and whisker plot for each year's scores using the same number line for each. Okay, so there's the box and whisker plots done. And let's look at some things that we're seeing here. First of all, the medians are the same value. Okay, they both have medians of 24. In 2011, their spread is much shorter. Okay, so they may not have scored as high, but they also did not score as low. All right, So a closer spread, can mean that the data is more predictable. All right. In 2012, we can see that it goes way further out, and in both directions, our whiskers are much longer. All right. The bottom line here is that even though the medians are the same, the median is better than the average for the data. Actually, this data is symmetric, pretty symmetric. But anyway, if we compared medians, the fact that they're the same doesn't help us by itself determine which year the football team did better, because clearly the data is different. So what we're calculating today is something called the interquartile range. Interquartile range. And let's shrink that highlighter down a little bit. Also known as the IQR. And what it does is it measures how far the data is spread from the median. It gives a realistic representation of the data without being affected by very high or very low data. Okay? It's kind of like if you just want to look at the middle set of data for your prediction purposes. Okay? How far apart is just that? Very high pieces of data can be outliers. Very low pieces of data can be outliers. So when we're using the IQR, it is to determine how reliable is the data, or how realistic is the data without those very high and very low. It shows the consistency. How consistent is the data? It is the middle 50% of the data, and it's calculated by subtracting the Q3 and the Q1. Okay, so calculate the IQR points scored for each year, then interpret IQR for each year.
Good morning, pardon the interruption. Any staff member that has 4L lunch duty, please report to the cafeteria at this time. Again, any staff member with period 4 lunch duty, please report to the cafeteria at this time. Thank you.
So I took the Q3 and the Q1 from 2011 and the Q3 and the Q1 from 2012, and we subtract those. 28 minus 17 is 11, and 25 minus 17 is 8. So here's what all this means. What all this means is that if we only look at, the size of this box, this is an 11-point difference. This is an 8-point difference. Yes, they did better in 2011 overall, because their box went further out. It started at the same place, but they had more middle scores that are higher. But the fact that 11 is bigger than 8 says they weren't as consistent. So we can take away from this that 2012 is more consistent. Their data is a little bit more predictable, but they're not as good as the year before. Okay? Okay, so we know what an outlier is. An outlier is a data value that is significantly greater or less than the other data values within the data set. But how big does it have to be considered an outlier? Okay, when we did scatter plots, if I drew a scatter plot and we had data that's roughly behaving like this, and let me put another data point. Nope, I want a circle. Here we go. So here's another data point that we're going to plot. All right. Certainly, if it's anywhere within these blue dots, it's not an outlier, okay? But what if I start moving it up? Is it an outlier yet? Well, it's above the dots, but it's still pretty close. Is it an outlier now? How about now? You know, when along this, area does this data point become an outlier? Okay, it's the same thing with our data. If we look at a set of numbers, let me go back to football scores. Okay, here we go. All right, if we go back to this set of numbers, 0 and 45. Those are, the highest and the lowest numbers. Is 45 big enough to be considered an outlier? Is 0 small enough to be considered an outlier? Okay, so there's an actual formula for figuring this out. Let's look at this set of data right here, and I'm going to blow this up a little bit bigger maybe. Nope, won't fit it. Okay, so let's look at this data right here. We have a low value of 2 and a high value of 30. Actually, while we're at it, 28 is pretty big as well. And we want to know, is 2 the low value? Is that an outlier? Is it small enough to be an outlier? 28 and 30, are those big enough to be outliers? All right, so first of all, you need to find your 5-number summary, which is what's listed right here. Your minimum, your Q1, your median, your Q3, and your maximum. Okay, so the first thing you're going to do is find your IQR. So the IQR was 7. Where did that come from again? That's the Q3, 13. Take away Q1, which is 6. So we've got an IQR of 7. Okay, then we're going to do this thing called find lower fence and upper fence. Okay, a fence is something that's going to hold data in, and anything that's outside of the fence is an outlier. Okay, so you take your Q1, which is 6. I am going to blow this part up here. Our Q1 was 6. And we're subtracting the IQR times 1.5. Now the 1.5, that's just part of the formula. You'll always use the 1.5. Okay, and that determines, once you plug that in, 6 minus 7, you get a negative value for your lower fence. So any values that are less than negative 4.5 would be considered small enough to be an outlier. So 2 is our lowest value, therefore it's not less than negative 4.5. That's not an outlier. But if we look at our upper fence, that's our Q3, 13, plus the IQR, 7, times 1.5. And I get 23.5 for that. Well, that means that the upper fence is at 23.5, and any value higher than that would be considered an outlier. So this 28 and 30, they are large enough to be considered an outlier. Okay? So some features I want to point out is when we're calculating the lower fence, this is a subtraction sign. And when we're calculating the upper fence, this is an addition sign. It's an important distinction to make. Okay, so let's look at the football data. To calculate our 2011 lower fence. Okay, 2011 lower fence. Too far. We're going to take our Q1, 17, subtract, parenthesis, our IQR 11 times 1.5. And get 0.5. So our minimum value is 10. That's not considered an outlier because it's higher than the 0.5. Let's calculate our upper fence. That's going to be our Q3 28 plus our IQR times 1.5. And that equals 44.5. Our max value is 45. That's wrong. Oh, kids, we got a typo. The max value was 35 for that set of data. There's a typo there. So, in 2011, 44.5, that's the upper fence. 35 is less than that, so it's not an outlier. Let's talk about 2012. Again, we're going to do lower fence and upper fence. So we've got Q1, 17, minus our interquartile range 8 times 1.5. And that equals 5. So our low value of 0 is considered an outlier. Okay, and anything, in fact, anything less than 5 is considered an outlier. Okay, our upper fence is going to be 25, our Q3, plus, instead of minus, 8 times, well, let's be consistent here, 8 times 1.5. 37. So in that data set, anything above 37, like our maximum being 45, that's an outlier. Okay, since we've got outliers in this 2012 data, let's go back and look at it. So keep 5 and 37 in your head for a second. Okay, so that 5 and 37 were our lower fence and upper fence. So here's 5. Okay, 0 would be considered an outlier. 37 was my upper fence. That would fit here. And so 45 would be considered an outlier. In the previous set of data, we didn't have any outliers. Okay? So that's how you can tell if a number is large enough to be an outlier. Your homework basically has 2 types of questions. It's giving you in the first set a set of data to look at that you'll put into your L1, and then you will get your Q1 and your Q3, and you'll write those down. Then you'll subtract those and get your IQR. Then you're going to use that IQR in these formulas. This example problem will show you step by step how to do it. Then once you have your lower fence value and your upper fence value, you're going to go back and look at the data. Okay, now if my lower fence is negative 8.5, that means I would need a low value, the minimum values, the lower values to be less than that. So any values less than negative 8.5 would be considered an outlier. 27.5 is the value of the upper fence. So anything higher than that, for example 30, is considered an outlier. Then you're doing the same thing but from a box and whisker plot. You're not entering in data, you're just having to recognize that here 7 is my Q1, 10 is my Q3, so I subtract those and get 3. And then again, sub the 3 into the Q1 and the 3 and the Q3 and the 3 into the two formulas, then look back and say there is, now you can't tell how many outliers, but you can tell any numbers. Alright, so for example, I know there's an outlier in the lower fence because, here, let me just pull this up here. Okay, so if my lower fence is at 2.5, that's roughly there, would be my lower fence. I know that at least my minimum value, okay, of 1 is an outlier. Now, I don't know how many values are in this area. I can't tell that from a box and whisker plot, but I know there's at least a minimum of 1, at least the minimum number. The upper fence is at 14.5. Well, 14.5 would be past, where we're going on the number line. So there's no outliers on the right-hand side. Okay? Thanks for watching. See you next time.